Hi. Close your eyes for 3 seconds. Now imagine walking across the street. You open your eyes, you instantly know where the road is, where people are, and whether it's safe to cross. What if machines can do this? That's exactly what computer vision is all about, teaching machines to see and understand the world. Computer vision is a branch of artificial intelligence that enables machines to see and understand images or videos just like we humans do. Instead of just storing pictures, the machines can actually interpret what's inside them. Think about how our eyes and brain work together. The eye captures light and sends it to the brain. The brain processes those signals, recognizes shape, and tells us that's a cat, that's a car, like that. Similarly, in computer vision, the camera acts like the eye, captures images, and the AI model acts like the brain, analyze and recognize what's inside. Now that we know what computer vision is, let's look at how it works. It's very similar to how our own eyes and brain process information. First step is capture. A camera or sensor takes an image or video. For example, our phone camera can take selfies. Second step is process. The raw image is just millions of color dots called pixels, and algorithm process this, detect edges, shapes, textures and colors. Think of it like the first step when our brain notices outlines and contrast. Third step is understand. Deep learning models like CNNs or transformers take those patterns and recognize objects, actions or scenes. For instance, the system may recognize this shape looks like 2 ears and whiskers, then it's a cat, like that. Fourth step is act. Finally, the system decides what to do with that knowledge. In a self-driving car, if it sees a pedestrian, the car applies brake. In a photo app, if it sees a friend's face, it suggests a tag. Computer vision isn't just in research labs, it's already part of our daily life. Let me share some familiar examples. First is face unlock. When you hold your phone to your face, the camera captures your features, compares them to stored data and instantly decides if it's you. That's computer vision in action. Second is autonomous cars. Self-driving vehicles use cameras to detect lanes, traffic lights and pedestrians. The car's eyes are cameras and computer vision helps it to decide when to brake, turn or accelerate. Third is healthcare. Doctors now use AI to assist in reading X-rays, MRIs and CT scans. For example, CV can highlight a tumor or fracture that a human eye might miss, helping doctors make faster, more accurate diagnosis. Fourth is retail. Have you heard of Amazon Go stores? You can just walk in, pick up products and can walk out. Cameras and vision systems track what you take and the system bills you automatically, no cashiers, no checkout lines. Fifth is social media. When you upload a group photo and Facebook or Instagram suggests tags like "Is this your friend John?" That's computer vision doing face recognition behind the scenes. These examples show how computer vision is everywhere, from the phone in your pocket to hospital, to the supermarket to your car. Computer vision has evolved far beyond recognizing cats or faces. Let's explore 5 of the most exciting trends shaping its future. First is Vision plus Language Models, VLMs. Traditionally, vision systems could only label objects like car, tree or person. But now, AI can understand and talk about images using both vision and language together. Models like CLIP and GPT-4V can look at an image and describe it in full sentences, answer questions about it, or even understand diagrams. For example, you can show GPT-4.7 a picture of a chart and ask what's happening here, and it will summarize the trend combining sight and reasoning. This fusion of text and vision is what powers modern AI assistants that see and talk. Second is text to image and video generation. Another trend is generative AI for vision. Tools like Stable Diffusion, Midjourney, and OpenAI's Sora can turn text prompts into realistic images or even videos. If I type a robot painting on the moon at sunset, the system can generate that picture instantly. This technology is transforming art, marketing, filmmaking, and design, where imagination meets automation. Third is 3D vision, AR, VR. Computer vision is also stepping into 3D worlds. Using depth sensing and reconstruction, AI can build digital twins, 3D replicas of real spaces using AR, VR, robotics, and metaverse applications. For instance, an architect can scan a room and instantly get a 3D model for virtual tours, or a factory can use vision board twins to simulate production before it happens. Fourth is medical breakthroughs. In healthcare, computer vision is saving lives. AI models can detect diseases earlier and more accurately than ever. Cancers, diabetic retinopathy, pneumonia, or bone fractures. They can analyze X-rays or MRI scans pixel by pixel and highlight anomalies for doctors. This isn't about replacing doctors, it's about giving them supervision. Next is ethical challenges. With great power comes responsibility. Computer vision also faces serious ethical and social issues. Challenges. First is data hunger, the fuel problem. Computer vision models, especially deep learning ones like CNNs, need huge amounts of labeled data to learn effectively. For example, training a self-driving car to recognize a stop sign safely might require millions of labeled images of that sign under different lighting, weather, and angles. Collecting and labeling such data is time-consuming, costly, and sometimes even impossible. That is, rare medical cases. Just like a student needs thousands of examples to learn handwriting patterns, AI needs millions of visual examples to see properly. Second is privacy issues, the ethical dilemma. Computer vision often uses human faces, license plates, or CCTV footage, this sensitive information. In public spaces, facial recognition systems can identify people without their consent, raising serious privacy and surveillance concerns. Some countries like Europe have already started regulating this with laws, which limits how data can be collected and used. Example, a camera in a mall could track customers' emotions or habits, useful for business, but it crosses privacy lines if people aren't informed. Third is explainability, the black box problem. When a deep learning model says this is a cat, we often don't know why it said that. AI models are like very smart but unexplainable students. They get the answer right but can't explain their reasoning. In critical fields like healthcare or autonomous driving, we must understand why an AI made a particular decision. Example, if a medical AI says an X-ray shows pneumonia, the doctor must know which region of the image triggered that conclusion. Otherwise, it's risky to trust it. Researchers are working on explainable AI to visualize what the model sees inside the image. Fourth is future of computer vision, which is smarter, fairer, and closer. The future of computer vision is promising and exciting because it's more accurate with better neural network architectures like vision transformers. Models are achieving human level accuracy in many areas. Second is ethical and fair. AI ethics will be a major focus, ensuring systems don't discriminate, protect privacy, and are transparent in decisions. Third is on-device of edge AI. Instead of sending images to large cloud servers, computer vision will run directly on phones, cameras, or IoT devices, which makes it faster, cheaper, and more private. Example, our smartphone camera already uses AI locally to enhance photos or blur backgrounds. That's edge vision in action.